This is Christopher Sernaque hosting episode 6 of season 4 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Today on Current Topics in Science, we have the honor of hosting Dr. Jake Hebert. Dr. Hebert earned his Bachelor of Science degree from Lamar University, his Master of Science degree from Texas A&M University, and a PhD from the University of Texas at Dallas, all in the field of physics, with his PhD research involving a study of the likely connection between cosmic rays, solar activity, and weather and climate. Before joining ICR, Dr. Hebert taught at both the university and high school levels. He joined the Institute for Creation Research in 2011, where he is a research scientist. Dr. Hebert has been researching the post-flood ice age, the dating methods used to assign ages to the seafloor sediments and deep ice cores, and cosmology, among other research endeavors. He's the author of the book The Ice Age and Climate Change, A Creation Perspective, and the booklets, The Ice Age and the Flood. Does science really show millions of years? And the climate change conflict, keeping cool over global warming. He's also contributed to the books Guide to Creation Basics and Beyond, and Guide to the Universe. And now, without further ado, good afternoon, Dr. Hebert. How was your day, and how are you doing?
I'm doing fine. Thanks for having me. I'm glad to be here.
Dr. Hebert, it is a pleasure and honor to have you on Current Topics in Science. And since this is Current Topics in Science, we're going to quickly look at this week's current topic. So today we're looking at a Science News article posted on March 16th at physics.org entitled, "Ancient Ice Reveals Scores of Gigantic Volcanic Eruptions." By examining chemical clues within deep ice cores from Greenland and Antarctica, scientists have concluded that many large volcanic eruptions took place during the last 60,000 years of the most recent ice age. 85 of these are thought to have been large eruptions, and 69 are believed to be larger than the 1815 eruption of Tambora in Indonesia, which is the largest observed volcanic eruption in modern times. This age of 60,000 years that they mention is much longer than the Bible's short 6,000-year timescale. And so some creation critics like Bill Nye, the science guy, they'll claim that deep ice cores are an unanswerable argument for an old Earth. So Dr. Hebert, how would you answer him?
Well, obviously, I disagree. There's really two. The main method that people use, the most common method of dating an ice core, are theoretical age models, and these are primarily used in East Antarctica, where they have the deep ice cores there, and those models implicitly assume millions of years. So the ages you get from East Antarctica, like the Vostok, the Apica Dome Sea, the Dome Fuji cores, those don't really prove anything, okay? Now, from Greenland, at first glance, it seems that they've got a stronger argument because they claim that they're obtaining those ages by simple counting of annual layers. And who can argue with simple counting, right? Well, it turns out it's a lot more complicated than people realize. And in the upper halves of the Greenland ice cores, okay, you do see banding patterns, okay, but it's not as simple as people think. It's not like you have one layer per year or even two layers per year. You have multiple distinct layers that can be deposited per year, and that number can vary from year to year. So they have to make an educated guess about how many layers should be grouped together and counted as a single year. And that is not trivial. But what's really interesting and what most people don't know is that when you get down about halfway through those cores, the banding patterns start becoming indistinct. You can't really count them anymore. But I like to ask people, what age do you think they've assigned halfway down those cores? Now, these cores in Greenland are about 3 kilometers thick. And they would argue that the ice at the bottom is more than 110,000 years old. So I like to ask people, what age do you think they assigned at the midpoint? If you've got an age of 0 at the top and an age of 110,000 or more at the bottom, I ask people, what do you think? And I get numbers like 50,000, 40,000 years. Turns out the age they've actually assigned at that depth is only 9,000, about 9,300 years. Now, what's interesting about that is we creationists think the ice at that depth is around 3,800 to 4,000 years old. So we think they're overcounting, but they're not overcounting that much. They're within a factor of 2 or 3 of what we think the true age is. It's only when you get very deep in the ice that the number it just blows up. And it is in the deepest parts of those cores where it is hardest to identify layers because, like I said, the banding patterns become indistinct as you go deep into that Greenland ice, but they can measure the amount of dust. And there is a seasonal dust cycle, so they think every time they see a spike in dust content, that represents a year. Well, the problem with that, though, is that you can have spikes in dust content within a single storm, a single snowstorm, okay? Now, we think that during the Ice Age, we think there was a lot of snowstorms. You're looking at conservatively thousands of these, okay? So when you impose that on top of the seasonal cycle, counting becomes much, much harder. And so it's a lot more subjective. Now, like I said, they will tell you that the ice at the bottom is about 110,000 years old. But what's funny about that is that's not the answer they got the first time. The first time they were trying to date that ice, they got an answer of 85,000 years, okay, which is still high. But here's what's funny. They didn't like that answer because that wasn't the answer they were expecting, because based on some sediment cores and their interpretation of the Milankovitch Ice Age theory, which we can talk about a little bit later, they thought the ice was supposed to be around 110 or 111,000 years old. So they did a recount, okay? They got a recount. They made the measurements at a much higher resolution, and voila, they managed to find those missing 25,000 years, and they were able to get the answer they wanted. So this process is a lot more subjective than people think, and it is not the slam dunk argument for an old Earth that some people think.
That's incredible, Dr. Hebert. And if you don't mind me going a little bit off script, I think that's pretty incredible. So essentially, they tried to use the different methods to see, hey, maybe we can compare and contrast. And if both of them all seem to be indicating the same thing, then it seems like we got some pretty solid evidence. But you're saying one said this and the other said this, and so they tried to fit this to make it say that.
Yes. And what's even more interesting is there were 2 scientists who did the recount, and one of the scientists consistently counted 20% more layers than the other. so they split the difference and just averaged the answer. Okay, so it's very subjective. It's not the slam dunk argument that people think, and that's true in both the Greenland ice cores and the cores from Antarctica.
So thank you so much for addressing that, Dr. Hebert. So when we look at these methods used to date the deep ice cores, so what we're seeing is that they're not exactly airtight. But is there any positive evidence that the ice age sheets of Greenland and Antarctica are actually young?
Yes, there sure is. Secular scientists, I don't mean that in a pejorative way, but scientists who don't hold to a creation view, they believe there's a mountain range in East Antarctica called the Gamburtsev mountain range. And they recently, from radar imaging data, they've been able to figure out what those mountains look like. They're under all this ice. and they were shocked because there was no evidence of really hardly any erosion. Now, for many, many years, they claimed that this mountain range is 1 billion years old, almost 1 billion years old. Okay, and they were just shocked that there was no evidence of erosion. I mean, they, to put that in perspective, they think the Alps should be gone in 100 million years. Okay, so to have a mountain range that is 1 billion years old and there to be no, when they look based on that radar imaging data, it's craggy, it's rocky, it hasn't been smoothed down like you would expect after all that time. Now, they came up with a couple of scenarios to try to explain the lack of erosion. And neither of them really worked really well. One idea was that somehow the ice protected it from erosion, and I guess in a theoretical sense, you could maybe argue that something like that might happen. But the other one, it was that, well, the mountain range really is that old, but somehow it got obliterated and then it got rejuvenated later. It kind of popped up again. And neither of these explanations, I don't think, were very convincing. And I'm pretty sure the evolutionists don't consider them convincing either, because recently I found a quote at a prominent, institution that does this kind of research, and they said that they're now trying. It sounds like they're now trying to float the idea that the mountain range is now less than 50 million years old, which that is a huge reveal. I mean, you're saying it's almost 1 billion years old. Oh, well, now it's only just 50 million years old. Well, the reason they're saying that, and of course, nobody's put their name to it, but their website kind of implies that maybe it's 50 million years old, is because they think the East Antarctic ice sheet is only about 34 million years old. Okay, so you could argue, well, if the East Antarctic ice sheet is only 34 million years old, well, then it was only exposed to erosion for maybe 16 million years. And okay, that might work. But the problem is they don't have any mechanism to cause that mountain range to be formed in their time scale, 50 million years ago. And the problem bothers them so badly that they said that finding that mountain range in East Antarctica is like finding an astronaut inside an Egyptian pyramid. There's no reason for it to be there. Okay, they are really, really bothered by this. Okay, so that is a very strong evidence that both the mountain range itself and the ice over it are a lot younger than what we're being told. Now, there's some more evidence, and I think the strongest evidence that the ice sheets are young come from Antarctica. There may be some evidence from Greenland, but I think the strongest evidence is from Antarctica. And within these deep Antarctic ice cores, you will sometimes have volcanic ash layers. It might be ash, it might be volcanic debris. They call that tephra. And you have these tephra layers that show up in the ice. Now, what's interesting, there are 3 ice cores in East Antarctica where they've assigned ages greater than 400,000 years. Okay, they're the Apica Dome C core, the Vostok core, and the Dome Fuji core. I believe that currently those are the only 3 that have ages that old. Now, what's interesting about that is that the tephra layers, if you do a graph and you show their position as a function of depth within the ice, there's not really much of a pattern. But when you plot them versus the assigned uniformitarian age, something dramatic happens. What happens is you have almost no eruptions at all more than 200,000 years ago, and then you've got dozens of eruptions that go boom, 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 that happen really quickly in time. Now, you think, well, why would that be? They have to argue that for some reason, volcanic eruptions were much rarer in the distant past. But I think there's a better explanation, and I think it's because their age models are cramming hundreds of thousands of imaginary years into the bottoms of those ice cores. You see, the age models typically assign about 85% of all the time to the bottom halves of the core. Okay, so if you've got a core that supposedly spans 800,000 years, when you take 85% of 800,000, that's a lot of time. There's just a little bit of time at the top, but there's a lot of time at the bottom. Now, what if those multiple hundreds of thousands of years are imaginary? What if they never really happened? Well, the ice is real. The ash layers are real. If you were to assign all these hundreds of thousands of years that never really happened, it's going to cause those tephra layers to seem extremely infrequent in time. And so I'm saying that this is a systematic effect of their inflated timescale. The fact that you have dozens of eruptions closely spaced together at the top, and then they just fall off at the bottom and hardly anything happens, I think that's because of their timescale. I think that is a clue that their age timescale for those ice cores is greatly inflated. So I think those are two really strong arguments that the ice is a lot younger than what they're claiming.
Thank you, Dr. Hebert, for sharing those evidences with us. And so while there is evidence of the usefulness of the Ice Age, we need to understand the philosophical frameworks at play here. Dr. Hebert, could you briefly explain the concept of uniformitarianism as well as what uniformitarian scientists believe about past ice ages?
Okay. Well, uniformitarianism is a philosophy that basically can be summarized by the motto that the present is the key to the past. So for a uniformitarian, they would argue that the kind of geological processes that we see going on today, they have always operated at more or less the same rates and intensities as they do today. So for a uniformitarian, something like the Genesis flood is out of the question. Okay, that's not on the table for discussion, and neither is biblical creation. So people need to understand, and Christians need to understand, that they have this philosophical framework that is not allowed to consider biblical creation. Okay, that's not on the table for discussion. And so they're trying to interpret the data within this framework. And I would argue that that framework is holding them back. Okay, there are things that they can't explain because of their belief in evolution in millions of years. Now, as far as what they believe about past ice ages, they believe there have been multiple ice ages throughout Earth history. They believe, I think they would argue there have been about 4 major ice ages hundreds of millions of years ago. Okay. Now, they believe that within the last 2.6 million years, you've had about 50 ice ages. Well, and I guess we need to define the term ice age. The way the experts define it and the way the guy on the street defines it are a little bit different. But the experts, what the average person would call an ice age, the experts call a glacial interval. Okay, if you want to get technical about it, they would claim that we're still in an ice age because we've got big ice sheets in Greenland and Antarctica. But the average person on the street thinks, well, an ice age, that's when the ice gets bigger. So they believe there have been about 50 cycles within the last 2.5 million years where you've had ice ages and then you've had warm periods and then you've had ice ages and warm periods. And supposedly the ice sheets are growing and getting smaller, growing and getting smaller all that time. And the dominant theory, okay, that they have for this is something called the Milankovitch theory. Now, the Milankovitch theory is not invoked to explain the prehistoric ice ages, the ones that are hundreds of millions of years ago. Those, the evidence the evidence for these previous ice ages is very weak. And I don't think they have anything other than hand-waving explanations to try to explain these supposed ice ages. We don't even think they occurred. We think they're misinterpreting the geological data, which is actually pretty scanty, okay? But there is good evidence for one ice age, a recent ice age. Now, even if you believe there were multiple ice ages, you're not going to expect the geological evidence for previous ice ages to be very strong. And that's because those glaciers are going to bulldoze and destroy the previous geological evidence for the other ice ages. So even if you believe there were multiple ice ages, the evidence for them is not going to be very strong. And we think there was just one ice age. And, it's funny how they've convinced themselves that there were 50 ice ages. Basically, that is coming from this Milankovitch theory. And I guess we need to define for your listeners what that is. The Milankovitch theory has been around for a long time, but it's the idea that changes in Earth's orbital and rotational motions control the timing of ice ages. Okay. And so, based on, little wobbles in the Earth's orbit and the tilt of the axis, there's going to be times when there is more sunlight, more summer sunlight hitting the high northern ice sheets at times in the prehistoric past. And so they think at those times when you have more sunlight, the ice melts and you get a warm period. And there's going to be other times when there's less light, they think the ice grows and you get an ice age. Well, how do they come up with 50 ice ages? Well, once they convinced themselves that they used data from some sediment cores to convince themselves that the theory is true. And once they did that, they used other data to try they used the Milankovitch theory to date other deep sea sediment cores. And so what they did was they constructed this composite data set that had chemical data from 57 different cores. And they used the Milankovitch theory to assign ages to them. And they put them into this big composite data set. And if you count the number of wiggle cycles, that you have that are less than 2.6 million years old, you've got about 50 of them. Therefore, they claim there were 50 ice ages. That's all it's based on. That's all it's based on. It's not based on clear geological evidence from land. It is based on a very, very shaky interpretation of that chemical data they're getting from these seafloor sediments. And now, later on, we can hopefully talk about why the Milankovitch theory is so shaky, but it's not strong at all. And if you want to be really hard-nosed about it, you could say there's no evidence at all.
Dr. Hebert, thank you for explaining uniformitarianism and then what current thinking about the Ice Age is based on. Speaking of which, you already mentioned some of them, but what are some of the problems with the mainstream Ice Age explanation, this Milankovitch or the astronomical, Ice Age theory?
Well, one big problem is that the changes in sunlight that would be caused by changes in Earth's orbital motions are very tiny. And it's hard to see how those changes in sunlight by themselves could cause an ice age. And for that reason, a lot of scientists who hold to this theory, they've convinced themselves that our climate is unstable because they think that somehow the climate system amplifies these tiny changes in sunlight, and you can get a runaway hothouse effect or you can get a runaway ice age. And so they have to believe that our climate's unstable. And that is coming directly from their belief in the Milankovitch theory. That's one of the big problems for it. Another problem is, as I said earlier, is there really any evidence for it? And this is something that I actually did some research on because we creationists have had a strong ice age theory for more than 30 years now. And it's very well developed. We've done a lot of work on this, but we had not done a whole lot of work critiquing the evidence for the Milankovitch theory. And so I thought, well, maybe we need to look into this. And so I was looking at how they date the seafloor sediments and the ice cores. And what I found is that the paper that convinced everyone that the Milankovitch theory is true, it is a 1976 paper that was published in the journal Science titled The Pacemaker of the Ice Ages. It's a very well-known paper. And what they did was they analyzed chemical wiggles in these cores that they drilled into the ocean floor, the deep southern Indian Ocean, and they assigned ages to those cores. And then after they did that, those wiggles seemed to tell a story that agreed with the Milankovitch theory. Because according to the Milankovitch theory, you should have these astronomical cycles that are around 23,000, 41,000, and 100,000 years, okay? Well, when they dated those sediment cores from the Indian Ocean, they had cycles of about 23, 41, and 100,000 years. And so that looked like really strong evidence for the Milankovitch theory. But what it turns out that you cannot use radioisotope dating methods to date the seafloor sediments directly, at least in most cases, okay? Because they think the methods that you could use to date the seafloor sediments can only date relatively young sediments. And if you're going to make a convincing case that the Milankovitch theory is true, you need at least 500,000 years worth of seafloor sediment data. Now, I don't accept those numbers, but just based on what they believe, if you wanted to make a convincing case, you need about 500,000 years worth. So in order to date that, they had to use a backdoor approach, and they used the age for the most recent flip of the Earth's magnetic field. Now, we creationists think that there were magnetic field reversals. We think those were caused by the Genesis flood, but they think that these magnetic reversals have happened, hundreds of thousands of years ago and millions of years ago. Well, in 1976, when they did that calculation, the accepted age for the most recent flip of the Earth's magnetic field, what they call the Brunhes-Matuyama magnetic reversal, was 700,000 years. And when they did that, they got the answer that they liked. Well, it turns out in the early 1990s, there were scientists who were trying to use the Milankovitch theory to date other sediment cores, and they were having trouble doing it. And so they suggested that they just revise the age of that magnetic reversal up to 780,000 years. Now, before that, they'd already bumped it up a little bit. They'd already bumped it up to 730,000 years. And that wasn't totally ad hoc. They had some fairly good reasons for doing that. But the 780,000 year jump was arbitrary. They basically said the radioisotope dates are wrong and we're changing the age. So they arbitrarily changed the age from 730,000 years to 780,000 years. Now, why is that a big deal? Well, guess what happens if you go back and redo the original calculations using, instead of 700,000 years, using 780,000 years? It messes up the results. And you've no longer got convincing evidence that the Milankovitch theory is correct. And so that's what they did. And so I did some research on this. I went and showed that that's what happens. And I had some papers published in 2016, 2017, maybe 2018, but I had a number of papers on this. It's one thing, you may say, well, Dr. Hebert, what do you know? It's one thing for you to say that, but I think I found evidence that the uniformitarians realized it too, because in 1996 they had this private meeting where they had paleoceanographers and all these Milankovitch scientists were meeting together, and there was a physicist by the name of Robert Mueller who basically was making some pretty strong criticisms of the Milankovitch theory. And we don't know exactly what he said at that meeting. Okay, we don't have a transcript, but there was a Science News article about it in 1996. And the article pointed out that he scored some points because he argued that there were elements of circular reasoning going on. Now, they didn't say exactly, well, they mentioned a problem, but I don't think they mentioned the main problem. They didn't mention the age of that magnetic reversal, but I think that had to have come up in the discussion, because the very next year, a very respected paleoceanographer by the name of Maureen Ramo comes out with a paper that purports to prove that the ice ages occur at the times predicted by the Milankovitch theory. Now, the reason that's so interesting is because they already had a paper that supposedly did that. Okay, this was a paper that was published in 1973. They referred back to it in that 1976 pacemaker paper. So if you already had a paper that proves that the ice ages are occurring at the right times, why do you need another one? Well, I think the obvious answer is because they knew that when they changed the age of that magnetic reversal, it messed up the results. And you get the sense from reading that Science News article that they almost panicked. In fact, there was a respected scientist there who was quoted as saying that Mueller scared the bleep out of them and they deserved it. And I'm pretty sure that this issue of that magnetic reversal came up. And I think they realized they had really messed up. Now, they have never candidly acknowledged this to either the larger scientific community or the general public. But see, that's why I say there's a serious question as to whether or not there's any real evidence for the theory. Now, some would argue, well, Dr. Ramo's paper, that's evidence. Well, it was kind of like, they realized, oh no, we don't have any evidence for the Milankovitch theory. We better come up with something quick. It was almost in a panic. And somebody who's more hard-nosed about it would say, well, is that very convincing? And if you want to be even more, you can make all these criticisms. Before they made that change, the sediment core that they used to date these other cores, they thought it was so important that they called it an Ice Age Rosetta Stone, because they thought that it was the standard that they could use to date other sediment cores. Okay. And that sediment core played a critical role in that pacemaker paper. So they were in love with that particular sediment core. And like I said, they called it an Ice Age Rosetta Stone. That's how important it was to them. Well, that was when it gave them the right answer. Okay, now that it no longer gives them the right answer, they don't make as big a deal about it. Okay, now it's just, in fact, some of the data looks like they've thrown it away. It looks like they've thrown away some of that data, which to me is inexcusable. Oh yeah, here's the thing. Talking about, do they have any evidence for the theory? Remember, the question is, can your theory be falsified? And if you really believed that sediment core was an Ice Age Rosetta Stone and it was the standard, then once they made that change, the Milankovitch theory should have been falsified. Okay, they should have said, we can't reconcile all the data with the Milankovitch theory, but they didn't do that. They just changed the numbers and went on their merry way until Richard Mueller called them out on it. And so they were going for like 4 years before, and the thing that's really troubling about this is I think the people who did this, I think they knew better. They were close enough to the original research. I think they should have, I think, and I'm not referring necessarily to Dr. Ramo, but the other people who were involved in that original pacemaker research, I don't see how they could have failed to have realized that making that change would have called the results into question. But they just ignored it and just went on trucking. And so it's very disturbing, because this has big implications for the global warming debate. Because one of the main arguments that our climate is unstable, and experts on both sides of the issue will tell you this is the real issue. Climate stability. How stable is our climate? The assumption that the Milankovitch theory is true is one of the main arguments that our climate's unstable, and that therefore we need to take drastic action to fight climate change. And what I'm saying is, I don't think they've got any evidence for the Milankovitch theory. Certainly not any strong evidence. And that has tremendous implications. And so I think it's outrageous that this information has been kept from the general public, and not just the general public, but from the larger scientific community for so long.
Dr. Hebert, it sounds like you're saying that the secular explanations for the Ice Age, they don't hold water, and they have very important implications for some of the discussions that are currently going on in our culture today. However, do the creationist explanations for the Ice Age fare any better? So for starters, I know you already mentioned this, but how many ice ages do creationists think occurred, and what evidence do we have to back that up?
Well, we think there was one ice age. And like I said, there is good geological evidence for a single ice age. So really, the burden of proof is not on us to prove that there weren't other ice ages. The burden of proof is on the uniformitarians to show that these other ice ages did happen. And the evidence for these supposed other ice ages is very weak, very weak. And so I think we're on very solid ground by arguing that there was not one ice age. If you think about it, in their model is very hard to explain an ice age. In fact, I can show you statements where they admit they don't understand in detail what would cause an ice age. Now, they think it's the Milankovitch theory, some version of the Milankovitch theory, but the details they don't know. And they're even now they are still coming up with new theories. They've got dozens of theories. I think the number now is actually over 100 different theories. And of course, that's an indication that none of them are really very good, because when you have a really good theory, it tends to cut down the competition. But when you've got all these other theories that even now, even within the last few years, they're coming with new ideas, that just shows you how poor their explanations are.
So, Dr. Hebert, it's actually really fascinating to see that the Ice Age is part and parcel of the creation model. So how exactly do creationists explain this post-flood Ice Age?
Well, we think it was caused by the Genesis flood. And, in order to have an Ice Age, basically what you need is you've got to keep snow and ice from melting for many consecutive years, okay? Because, when you have snow and ice in the winter, normally the following summer it's going to melt, okay? But suppose that you can keep at least some of that snow and ice from melting. That means the next winter you get more snow and ice. And if you can keep most of that from melting the next summer, the next winter you get more snow and ice, and you're going to get thick ice sheets, okay? So we know there were fairly thick ice sheets during the Ice Age. So the question is, how do you get those thick ice sheets? Well, you've got to keep the snow and ice from melting for many consecutive years. And in order for that to work, you need two things. First, you need cooler summers, which is kind of obvious, right? If you want to keep the snow and ice from melting during the summers have to be colder. But you also have to have heavy snowfall, because if the snowfall is light, the sunshine can melt it even when you're below freezing. Okay, so you need thick. It's got to be heavy snow, and you've got to have cool summers. Now, the reason this is so hard for uniformitarians is because those seem to be contradictory requirements. Because it's kind of paradoxical, but when winters are very cold, you get less snow, not more. Okay, so you don't need cold winters. You need mild or warm winters, cool summers, mild winters, cool summers, mild winters. And that has to go on for many years. And that seems very unlikely. Okay, that just doesn't. So is there another mechanism that could give you heavy snowfall in cool summers? And there is. We know that there is something called volcanic cooling. When you have giant explosive volcanic eruptions, there is a cooling effect during the summer. It doesn't do much to the winter temperatures, but the summers get colder. And so if you could have a bunch of volcanic eruptions putting aerosols up in the stratosphere, that's going to give you a cooling effect. Also, we know that if you could somehow warm up the oceans, you're going to get a lot more precipitation. Because when you have significantly warmer oceans, you get a lot more evaporation. That puts a lot more moisture into the atmosphere, and you're going to get more rainfall and more snowfall. Now, we think the Genesis flood provides us what we need for both of those things. We have a theory of the flood called catastrophic plate tectonics by Dr. John Baumgartner. He's one of the world's leading experts, if not the leading expert in that field. And he thinks that there was catastrophically rapid movement of the plates during the flood. And at ICR, we think he's right. And that means that you would have had a new seafloor being formed very rapidly. And so, when you have a new seafloor, that's lava. Okay, that's lava coming into contact with this ocean water. It's going to warm up the oceans a bunch. And that's going to give you the heating you need to get warm oceans. And it's going to take hundreds of years for the oceans to cool back down. And so that's going to give you the evaporation. That's going to give you the moisture you need for heavy snowfall. And we think that after the flood, those volcanic eruptions that were going on they're not going to come to a screeching halt. They're going to keep going for hundreds of years, but with gradually decreasing intensity. And so that's going to repeatedly put aerosols up into the stratosphere that will give you the necessary summer cooling you need for hundreds of years. And so basically that's what we think explains the Ice Age. And it very naturally comes from the Genesis flood. We think that the flood is the key to explaining the Ice Age.
Dr. Hebert, thank you so much for outlining the young Earth creationist model of the post-flood Ice Age. I want to ask you, though, so these ideas were interesting, but obviously there's going to be people who would like to say, I don't think that's true. So what are some criticisms of this theory, and how would you respond?
Well, the big criticism is that, you would have and it's really, I don't know if it's a criticism of the Ice Age model per se, or if it's a criticism of the flood model. But you're looking at a tremendous amount of geological work being done during the flood, and there's going to be a lot of heat involved. And so, a lot of them say, well, hey, that's too much. And to be candid, there are some respected creationists who think God may have used a miracle to dissipate some of that heat. So that's a real issue for us. But here's how I would respond to that. They've got the opposite problem. Okay, their Ice Age mechanisms aren't strong enough to get the job done. Now, ours may be too strong, okay, and we think God may have done something to alleviate some of that heat. And if you think about it, you can't have a flood without at least some miraculous elements. I mean, the very fact that God told Noah to build an ark means he had over a century's warning that this was going to happen, okay? So if the flood happened, and we think there's overwhelming geological and paleontological evidence, not to mention historical evidence that it happened, if the flood really happened, and we think it did, we think there's strong evidence it did, something had to change. Okay, if you have the plates start moving, first of all, we don't think there were any plates to begin with. We think the plates were formed during the flood. Okay, so for the continents to start moving and for that, something big had to have happened. And a lot of us think that accelerated radioactive decay generated the heat that triggered the flood. Okay. And so we talk about accelerated radioactive decay and how that messes up the dates obtained by radioisotope dating, but it's not capricious. God has a reason for doing it. Okay, we think the heat generated from that is probably what triggered the flood. So in a sense, the trigger for the flood itself, you could argue, had a supernatural element. And it may be that God did do something to alleviate some of that excess heat. Now, secular guys, uniformitarians are going to hate that answer. But, the thing is, if we're really honest, everybody believes in miracles. Okay, and they do too. Okay, they have to invoke miracles. They invoke miracles for the origin of life. You hear uniformitarian physicists even claiming that the laws of physics may have been different in the past. So I don't know how if they've got a strong case for being too critical here. Now, I'll admit that this is one of the big issues with our model, but I don't think it's fatal. And I think, and like I said, I would rather have a mechanism that is too strong and you can dial it back a little bit than to be in their shoes and have a mechanism that is not strong enough to get the job done.
Dr. Hebert, thank you for taking the time to consider and then answer a criticism that's brought up against the biblical model. By the way, when I was reading your paper, Developing a More Rigorous Ice Sheet Model, I noticed a key word that has become a calling card of sorts that distinguishes genuine science from pseudoscience. You wrote, the flood ice age model predicts thicker annual layers than uniformitarian models do. And so with that in mind, Dr. Hebert, can the creation flood model make testable predictions? And if so, what are they?
Yes. I think, in fact, I've made a prediction recently. There are plans to drill another deep ice core in Antarctica. And they are hoping to get down to ice that they think is 1.5 million years old. Now, obviously, we don't think the ice is that old, but I'm hoping that they're successful. because I think that same pattern that we see in the tephra, the volcanic ash layers, I think it's going to show up in this other core. Because I'm arguing that is a systematic error due to their inflated timescale. So I'm predicting that same pattern is going to show up in this ice core. And there's a chance, we don't know exactly where the volcanic tephra layers will be. Okay, but let's suppose that you've got a tephra layer that's deep in that ice. And let's suppose that it's an ice that they think is 1 million years old, but it's really just 1,000 years old. Their time scale would be inflated by a factor of roughly 1,000. So, these volcanic eruptions are very short events. Okay, they happen very quickly. The ash falls out quickly. Okay, even when you take into account the time it's in the atmosphere, they're not up there for very long. So I'm thinking there's a very good chance, and you can't be sure because we don't know exactly where the ash layers will be or how thick they'll be, but I think there's a very good chance that if they get down to ice that they think is 1 million years old or more, that you could have their time scale could imply ridiculously long fallout times for that volcanic debris. Like instead of maybe a week or two, it might look like it was deposited over 10 or 20 years. Okay. And so we've already got a little bit of evidence for that. There's some evidence in one of the Antarctic cores that it looks like their time scale is inflated based on how much time they're assigning to the ash layers. But I think if they succeed in getting this other core, it's going to be worse. And I think I think it can only really help the creation model. I think they're going to possibly end up shooting themselves in the foot, because I think if they get that ice that they think is 1.5 million years old, the problems with their time scale, I think, are going to become even more obvious.
Those predictions were very fascinating, Dr. Hebert. And I'm wondering, we already kind of mentioned this earlier, but does all this have any implications for the issue of global warming or climate change?
Oh, yes, absolutely. Okay. Again, experts on both sides of this issue will tell you that the heart of the debate, it's not whether or not it's getting warmer. Okay. Because, maybe it's getting warmer now, maybe it's stopped, maybe it could get warmer later. The heart of the debate is what they call equilibrium climate sensitivity. Everybody agrees that if you were to double the amount of atmospheric carbon dioxide, there's going to be a slight temperature increase, but not much. Okay, the question, though, is what happens after that? Because the climate system is complicated. If you change one thing, that changes something else, which can change something else. So you have these feedbacks. Okay, those feedbacks could theoretically amplify the warming, or they could inhibit it. Okay. Now, if you think equilibrium climate sensitivity is high, that means that you have all these positive feedbacks that amplify the warming, and then you can have an out of control situation where you have extreme global warming. On the other hand, if climate sensitivity is low, you're going to have negative feedbacks that kind of pull everything back to equilibrium, and you're not going to get much of a change. So people who are worried about global warming think equilibrium climate sensitivity is high. They think it's high, and which means basically that our climate's unstable. Well, again, one of the main arguments, okay, for an unstable climate or high equilibrium climate sensitivity is the assumption that the Milankovitch theory is true. Okay, and what I'm saying is, based on our research here at ICR, there is little to no evidence for the Milankovitch theory. It's basically all circular reasoning. And whether or not you say there's any evidence for it depends on how generous you want to be. But the evidence for it at best is extremely shaky. And frankly, I think our policymakers deserve to know this. They need to know that one of these arguments, one of the main arguments for high equilibrium climate sensitivity, is coming from speculation that has basically nothing behind it. And I think the average person on the street needs to know this. And so, yes, it very much has big implications for the global warming debate. Absolutely.
Dr. Hebert, We've now come to our final question. At the beginning of this interview, you expressed your deep faith in God and His Word. Can you tell us, how has examining the evidence from science strengthened your faith in Christ Jesus?
Oh, it has strengthened my faith. I mean, the fact that taking the first chapters of Genesis seriously helps us explain the Ice Age. That is tremendously encouraging. And a lot of Christians out there, it's almost like they're embarrassed by the Bible's short 6,000 year time scale. It's like they think it's something they have to sheepishly apologize for. And what we're seeing here at ICR is that, no, that's not the case. The Bible's 6,000 year time scale, the Genesis flood, those are the keys to explaining Earth history. And there are things about Earth history that we as creationists can explain that are still mysteries to uniformitarian scientists. And so we're on the right track. And, taking the Bible seriously is the right way to do science. And we're making all these discoveries. The evidence for recent creation is not getting weaker. It's getting stronger over time. The case that we're making is getting stronger. We're finding all the time, we're finding more evidence that confirms what the Bible says about Earth history. And so that's something that I think Christians ought to be very encouraged by. And so if you'd like to learn more, we'd encourage you to check out our website, icr.org. We've got all kinds of videos, we've got books, we've got podcasts. If you'd like to learn more about this, so we've got plenty more information for those who would like to learn more.
Dr. Hebert, thank you very much for your time. It was an absolute joy. And to our listeners, thank you very much for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find Dr. Hebert's biographical information, his book and DVD on the Ice Age, and articles in the description. Please share and subscribe to the Current Topics in Science podcast. It's available on iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.